Good morning, good afternoon, good evening to USA, Europe, and Asia attendee. Welcome to Composable GPU webinar. I'm Brian Pan, General Manager of H3 Platform, and I will present world first PCIe Gen4 Composable GPU to you. We have two other folks here.
Hi everyone, I'm Gisbert. I will facilitate today's webinar. Welcome all of you.
Hi everyone, I'm Jun. I will do the demonstration today. Thank you.
We will work together on today's webinar. Before going to the agenda, I would like to invite all the attendees to ask questions if you have during the presentations. I will answer the question during the webinar. And of course, we also have the Q&A sections in the end of the webinar. Now we will turn off the camera and give you the full screen presentation. Today the topic is PCIe Gen4 Composable GPU Solutions. I will talk about the GPU low utilization issues, how we use a composable GPU solution to provide the right size GPU to solve low GPU utilization issues. Then we will talk about the solution architectures, demo two main features, Composable and Analytics, show our product portfolio. Then we will go through other features, key benefit, and a Q&A. This is a statistics of the GPU utilization rate in average from one of the data centers. The y-axis is the utilization rate, and the x-axis is the percentage of users. On the very left columns, nearly one-third of GPU usage is under 15% utilizations. Only 25%, only 26 usage is over 75% utilizations. The average GPU usage is around 46%. It's a lot of GPU wastings, especially for expensive GPU. Why the utilization is so low? The main reason is that GPU are idle. AI experts take lots of time to do AI experiments and the result investigations. At that time, GPU is much underutilized. The other reason is that the efficiency of AI code. It means that the AI code does not fully utilize GPU. In rendering, it's the same situations. User either wait for rendering or waste the GPU resources. This is a kind of chicken egg issues because GPU are under low utilization rates and cannot be shared among users. Customers usually purchase mid-range GPU in order to save the purchase cost, especially in rendering. Then the mid-range GPU take longer time to do the rendering job compared to high-end GPU. Designers know that the rendering jobs takes a lot of time and will go to have coffee or eat lunch when starting the batch rendering. If you can provide a high-end GPU and share these high-end GPUs when not in use, the designer's productivity will be much higher because they can check the results much quicker and move forward to the next job. The total cost of composable GPU will be much lower than GPU servers. Besides, the integrated GPU servers is very difficult to upgrade. the components separated, such as GPU, CPU, memory, and so on. Here is the H3 platform PCIe Gen4 solution usage case. IBM Watson Lab tested our PCIe Gen4 composable GPU solutions over 2 years. Here are the main reasons why IBM chose our composable GPU solutions. Different AI, such as voice recognitions, need 1 CPU to 1 or 2 GPU, while image deep learning need 1 CPU to 4 GPU or even more. You need to mix different AI in the same GPU clusters. Another usage scenario is a DevOps usage. User can mix development and operation stage in the same GPU clusters. For example, when developing the AI algorithm, the GPU can be released for other AI experts. For AI experts, the servers are always the same servers. Only the GPU are added to the servers they use. So it saves lots of expert time in development and AI training. From the technology evolutions, composable is a key trend in past 5 years. The optimized composable solutions will be GPU, then memory. With these composable solutions, you will have the right size of resources for any of your applications. Besides, the composable solutions also increase the system reliability, availability, and serviceability. Here is the full system architectures when using PCIe composable GPU solutions. From user view to physical servers. Let's see the light blue area. You have the physical server and the GPU chassis. This server and the GPU chassis are connected by CDLP cable, which is running PCIe Gen4 protocol. The GPU in GPU chassis could be dynamically provisioned to any connected server. This is the composable GPU solutions. Let's take the left columns as example. You provision a GPU to the server 1. Then server 1 become a composed a GPU servers in the light orange area. The light orange area is the normal virtualization usage case, such as VMware, KVM, and so on. For those virtualization software, the composed a GPU server is exactly the same as one physical a GPU server. The demo topology is shown as the diagram. In this GPU clusters, 1 AMD PCIe Gen4 servers, 1 Intel Gen3 servers, and 1 16 GPU chassis are connected through CDLP cables. The PCIe devices, NVIDIA's 2P100, 3P400, and 2 Samsung PCIe Gen4 NVMe SSD. These 2 PCIe Gen4 NVMe SSD are preliminary sample. All PCIe devices can dynamically provision to AMD and the Intel servers. Then we will show you the features in 2 different parts, composable GPU and the analytic features. The composable is the dynamically provisioning capability. The analytics are the GPU core utilization and PCIe throughput performance. Before moving to the solution demo, I want to ask if you have any questions, please type it and we will answer your question. Now let's move to the demo. you see the topologies this is 4 hosts here, and there is a 16 GPU slots here. So let's go to see how many devices and what been connected. On the green one, that's AMD ROM servers, and the orange one is Intel PCIe Gen4 servers. Then you have two P100 here, and P400 here, 3 P400, and then we have two NVMe SSD PCIe Gen4. So let's go to then let's assign two P100 to the AMD server first. So let's go to see the terminal of the AMD. So there should be no any GPU in it. Okay, there's no any GPU in it that you can see it. So let's assign two P100 to AMD servers. Then of course this two GPU will be hard plugged in into AMD servers. Okay, so they are doing the background hard plugging. Okay, so then let's go back to check the AMD. Okay, so you got two NVIDIA GPU on AMD servers. So now we will do the P2P test of this P100 to see whether it works fine for the P2P performance test. Okay, so the so-called P2P is that they should not copy the data to the AMD server. So you should get the P100 P2P like 13 gigabyte, 12.5 to 13 gigabyte per second. Okay, here is the PCIe performance monitoring. You see the P2P is running, and then you got around like 13.8 gigabyte in from both. I mean, so it's around like 13.8 or 0.9 gigabyte per second for the P2P. So there is a running real P2P. So let's stop the P2P. Let's do the host to device. Because this two P100 is a PCIe Gen4 by 16. So in aggregate should be PCIe Gen4 by 16. So let's see what's the performance coming from AMD to Gen4 server to NVIDIA's GPU. Okay, it started. So you got 23.6 gigabyte. Yeah, as you know that if you use a Gen3, they probably can reach like 13. But now we use a Gen4, so it got 23.6 gigabyte per second. So it's aggregate to PCIe Gen3 performance to the Gen4 performance. Okay. So while doing that, now we will do another thing is that we will add two NVMe to the Intel servers at the same time. Then we will do the FIO test. So there's a two NVMe SSD. You select two NVMe SSD, then select Intel server, then allocate. So it means that these two NVMe devices will be added to the. Okay, so it's finished. Added to the Intel server. So we do the FIO test to see this two Gen4 by 4 should aggregate because it means Gen3 by 8, right? So it's two Gen3 by 8. So it's roughly Gen3 by 16 performance. So you roughly will see like one Gen3 by 16 performance. Okay. So let's see what performance they can get. So it's running. So it's run like 7,000, almost 280, 300. There's a 7,300 megabyte per second. The GPU is preliminary. So you see that NVMe is send some preliminary NVSSD sample. So one is just run at 3.5, but the other run is very normal. They run 7.2 gigabyte per second. So the 7.2 gigabyte per second is a correct one. It's running at a Gen4 by 4 performance, but the other one is not. So, but anyways, when you see the performance, you see we running GPU host to D and also a VNE FIO test at the same time. So PCIe switch is still very busy, right? So let's go back to the P2P. The P2P performance still like 23.6. There's nothing been affected by the new added FIO test. Okay. So this is the performance test. So in the Composable GPU Solution, we also provide features that you can configure the port. So we have a port configurations capability that you can change the port from host port, from device port to host port, or you can use bifurcation device, like you have a 2x8 devices or 4x4 devices. Yeah, of course, when you do the PCIe port configuration, you need to reboot the system in order to regain the trend. But anyways, you give you the flexibility for your different PCIe devices. Okay. So we also provide the device informations. So in the device list, you can see all the device list. And then if you click it, you will see one detailed information. For example, let's take P100X, for example. Then you can see the model name, the GPU UUID, and the firmware versions. If they provide a utilization rate, you also can see the GPU utilization rate from Outband. Okay, so it means that you can map in the physical port, which device in which physical port to the which server. Okay, then we also provide summary informations. In summary information, you can check how many resources that you have, how many available resources. You can see the GPU utilization rate. And of course, you also can see the PCIe performance in the past 2 hours, 72 hours. And then we also check some of the error, like PCIe bus error and GPU memory error. Okay. Now, if you have multiple units in your GPU cluster, for example, you have 10 units in your clusters, we provide a central management software. In the central management software, you will collect all the GPU chassis information, and will show which devices been assigned to which host, and which host is connected to which GPU chassis. So here is the example that you see there's an AMD ROM server and the Intel PCIe Gen4 servers are connected to one of the chassis. And you see the dot blue line. The devices, the 2 GPU are being assigned to AMD ROM, and the 2 NVMe being assigned to Intel Skylake. Okay. So this is a demo that we show it to you. We show it to you the composable capability, the dynamic assignment, hard plug, and the server can use as its normal. Then we do the performance test, including the P2P and the host to D in GPU, and the FIO test. Then we show you the port configuration capability and the detailed device information. Then also the the summary informations that you can get from the summary table. And then we also show you the central managements for the demo. So any questions, feel free to ask. If not, then demo is finished. Okay. So let's go back to the presentation file. Okay. So the product portfolio that we have two different PCIe Gen4 solutions, 16 GPU models and 8 GPU models. 16 GPU models support up to 4 hosts, and 8 GPU models support up to 8 hosts. All GPU slot is a PCIe Gen4 by 16 and backward compatible with PCIe Gen3 devices. Here is a specification of 16 GPU chassis. You can find the details on www.h3platform.com. Now I will go through the GPU cluster topology. The topology consists of a number of hosts and GPU chassis in the GPU clusters. Each host can up to how many GPU? This is the largest GPU group. It's 4 hosts to 2 16 GPU chassis. Each host can get up to 16 GPU. The large GPU group is 2 hosts to 1 16 GPU chassis. Each host can get up to 16 GPU. The average GPU group is 4 hosts to 1 16 GPU chassis. Each host can get up to 8 GPU. The small GPU group is 6 hosts to 1 14 GPU chassis. Each host can get up to 7 GPUs. Here is 8 GPU chassis. The average GPU group is 2 hosts to 1 8 GPU chassis. Each host can get up to 8 GPU. The small GPU group is 4 hosts to 1 8 GPU chassis. Each host can get up to 8 GPU. Please be noted, the host connections is PCIe Gen4 by 8, not by 16s. All the topology that I show you are the server HA architectures. If one of the server is failed, the GPU could be reprovisioned to another servers. So now we have to show you the demos, right? This is all the features, but some of the features we cannot demo to you, then I will quickly go through it. We also provide user management in our solutions. There are 3 different roles, like super admin, user admin, and the users. Super admin can manage all the machines. And in many usage scenarios, users are categorized into different user groups, such as image AIs, medical, voice, and so on. Each user group are granted some servers and a GPU chassis. Each user group have a user admin to manage the granted server and the GPU chassis. Of course, user admin can reprovision GPU to any users in the same group in order to have better flexibility. So it means that not just the IT people can have to reprovision the resource. User admin have there's a capability to manage their own group resource reprovisioning. If you have a multi-GPU chassis, you need a central management software to manage the all GPU chassis. The central management software is installed in one VM. All the GPU chassis and the central management module is connected through 1 gigabit management network. Super admin can manage any unit through central management software. We also integrate OpenID Enterprise Directory Service in our solutions. Users can see their existing Enterprise Directory Service to manage the user authentications. If customer has the central log servers, we can also send a log to central log servers for records and analysis. Our security policy is compliant with TLS 1.2 spec. PCIe hard plug is fully defined in PCIe 3.1 specification. Then is implemented in some host. The BIOS of the host should allow the request resources from PCIe switch. The device driver should allow the hard plug operations. In GPU hard plug, the GPU operation should be stopped, then do the GPU hard plug. Regarding the compatible OS, let's see the next page. Here is a list of our compatible OS versions. Red Hat, CentOS should be higher than 7.2. Ubuntu is 16.04 over 18.04 long-term support versions. Windows is Win 10 Pro version. Here are the compatible PCIe devices, NVIDIA's and AMD GPU. NVIDIA V100 Super has not been tested, but we will include in this GPU in our compatible list. Samsung and Intel SSD has been verified. Mellus Carnex 5 and Carnex 4 and Carnex 5 are compatible too. Today we go through why PCIe composable solutions in AI and rendering usage case. Talk about the technology trend, the system architectures of PCIe Gen4 composable GPU solutions, and we demo the features, show you the product portfolio, other features, and the compatibility list. If you want to search more detail where you can find required information. We have our website have plenty of information. You can see the products like the 16 GPU solutions. You have the specifications, the detailed specifications. You got data sheets to download. You have the photo that you can check. The insights and the products itself. And then in the solution side, you can see the Compose AI. So in the Composable AI, you can see how we explain the architecture, software architectures from physical view all the way down to the user view of virtualization and user view. And yeah, you also can see lots of our information on about. Okay. So let me go back. We have plenty of information on our website, and we will put more in the futures. Except the website and the email, you can reach us through online chat for any questions. If you or your customers want to see any specific features or customized configurations, feel free to send online request demos, and we are more than happy to show the composable GPU solutions. Okay, so today we have talked about lots of our solutions. Now you are very welcome to ask any questions. Any questions? Okay. I saw from Ritesh. Ritesh say, what is the maximum power for GPU? Okay, we have the onboard. We have the onboard 70 watt standards, so it could be used like a NVIDIA T4 that is kind of 75 watts power. We have extras 225 watts from board to the GPU. So we will provide a cable, a small GPU cable for single GPU. He can up to 300 watt. 75 watt is on board. 225 watt is coming from the motherboard. Any questions? Okay. Aaron will ask one questions. All the features you show can be done without shutting down the server and the GPU chassis, right? Yes, it is. So that's why that you see that we do the hard plug in of the devices. There's nothing wrong with the GPU and it works as normal. In fact, we also can do the remove the devices from the server, but because of the time limitation, so we did not do that. Okay. So it is okay that it's you keep always the machines online. Then we do the device allocations, reprovision to any connected server and host. Any other questions? Alex asked the GA schedule. Okay. The GA schedule is January 2020. So we already received some of the orders and we will start to shipping in the end of January 2020. Okay. Okay, so any other questions? Dan, do you have any questions? Okay, so there's no any new questions. If you still have any questions after the webinars, please feel free to drop in an email or request on our website. Thank you very much for joining our webinar. Goodbye and have a good day. Bye-bye.